Question 2 says, two hikers, hiker A and hiker B, hike along a straight track over the time interval 0 to 10, where t is in seconds. Hiker's A velocity is represented by a piecewise linear graph. Hiker's B velocity is modeled by this function here. Part A says find and compare the velocities of each hiker at t equals 2 seconds. Include units. Well, okay, let's start with hiker A. This is the velocity, and they want us to find the velocity at t equals 2. So one thing that we could do, at least right off the bat here, is we can estimate what the answer is. It looks like the answer is around 6.5. But that's just an estimation. Let's do a little bit better than that. What we're going to do is we're going to actually find the equation of this line right here. So to do that, we're going to find the slope first, which is up 10 and over 3. So that's the slope. And then the y-intercept, you can see, is 0 here. So our equation is y equals 10 thirds x plus 0, or just 10 thirds x. Now we can plug 2 in here. So y is equal to 10 thirds times 2. And if you plug that into a calculator, you get 6.667, which is pretty close to 6.5. So I know that's definitely correct. Okay, so that's for hiker A. Now let's go to hiker B. They gave us the equation up here, so we just need to take 2 and plug it in. We don't have to find the equation, unlike the last one. And if you plug that into a calculator, you get 6.857. Now it also says to include the units. Well, let's see here. T is in seconds. And what else do we know? Feet per second. Okay, so the velocity is feet per second for both of these. B says determine and compare the accelerations of each hiker at t equals 2. Include units. Okay, well, let's start with hiker A. This is a graph of velocity. We want acceleration, so we have to think about the derivative. So really, all we have to do is consider what would the tangent line slope be when t is equal to 2. And all we have to do is just think about the slope of this line. That's the beautiful thing about straight lines. They're very easy to work with. So the acceleration, let's write it like this. Let's see, this is hiker A. The acceleration at t equals 2 is just 10 thirds. It's just the slope of that line. Now, for hiker B, we got to do a little bit more work here. What we have to do is we first have to find the derivative and then plug 2 in. So let's come over here. We're going to find the derivative. So we're going to use the quotient rule here. So we need the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator all over the denominator squared. And then you're going to plug 2 into here. You can actually have your calculator do all of this work for you at once, because you can just give it the function and tell it to find the derivative at the point, and it'll give you the answer right away. If you're going to do it this way, you have to find t everywhere and plug in 2 and then have the calculator do it. But what we get is 1.469. So that's the acceleration at time t equals 2 for hiker B. Now it does say to include the units. This is acceleration we're talking about, so this is going to be feet per second squared for both of them. Part C says calculate the total distance each hiker travels over the entire 10-second interval. Include units. Well, okay, we have velocity over here. We're trying to find the total distance. So really what we're going to end up doing here is we're going to be integrating hiker A's velocity here. Because when you integrate velocity, you're going to end up with, or actually let me put it this way, if you do the definite integral of velocity, you're going to get the total distance. In other words, really what we're going to do here is we're just going to find the area under the graph bounded by the x-axis here. Now be careful, the x-axis is just a little bit above here. You can see they gave us a little bit of wiggle room down here when they did this. So this is what we're going to find here. Okay, so let's start with the easier one, the rectangle. We just need to do base times height, right? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is going to be 70 here. Over here we have 3. 3 times 10. So let's see here. That will be 15. So we just have to add these two together. 15 plus 70. And here, let me write it out down here. This is hiker A. 15 plus 70 is 85 feet. Okay, now for part B, what we're going to do is we're going to integrate velocity, just like we did over here, except we don't have a graph, right? We're just going to integrate this. Now, when you integrate, you're trying to get the total distance. So when you do this, you have to make sure that you do the absolute value of that thing. Now, I've got some good news for you here. If you consider the fact that we're going from 0 to 10 here, and this is 24t over 2t plus 3, if you plug in any number from 0 and up to 10 into this equation, you will always get a positive result, meaning we don't need the absolute value bars for this particular question here, right? Because absolute value just guarantees it's positive. Well, it's already positive, so we don't need that. So we can just straight up integrate this without the absolute value bars. Nothing wrong with including them in there. I mean, your calculator can certainly handle it. But if you were going to try to do it by hand, you definitely would want to make your life as easy as possible by not having the absolute value bars. I am going to use a calculator, though. And when I do this, I get 83.336 feet, like this.
If you found this video helpful, you might consider checking out my website, which is linked in the description below. You'll be brought to Infinity Learning Academy, where you can find Cruising Through Calculus. At Cruising Through Calculus, we have over 100 videos and documents to help you get through your calculus class, including videos for each topic, practice problems, and full video solutions for those practice problems. I hope to see you there, and together we can cruise through calculus.